Welcome to Chemistry with Caroline. In this video, we're going to look at the Gatterman-Koch formylation reaction. So that's the introduction of a formyl group to a benzene ring. A formyl group is just a carbonyl that has an H on the end. So let's look at a benzene ring starting material. This reaction is going to use carbon monoxide and HCl, which we will see generates our electrophile. And then, similar to the Friedel-Crafts acylation, it has an aluminum chloride catalyst and then also a copper chloride co-catalyst. And so we're going to introduce a formyl group, which is a carbonyl, and then it has an H on the end. That's what makes it a formyl group. So this little guy here is formaldehyde, and so that's why they call it that. So this functional group that you're introducing specifically is an aldehyde because of the presence of that H. So the difference between a Friedel-Crafts acylation and a formylation is that the formylation is an aldehyde, the Friedel-Crafts acylation is a ketone. So let's go to the next page and we'll take a look at the mechanism. So most of these reactions will start out with the generation of a good electrophile. The electrophile in this case is generated in situ or in solution from the combination of carbon monoxide and HCl. So it makes this acid chloride that has an H on it. The reason we generate it in solution is because it's just really unstable. This thing would polymerize and react, so you can't store it in a bottle. So you make this, and then it's going to look very much like the Friedel-Crafts acylation, the difference there being, again, that H versus a Cl. So in order to make a good electrophile, that aluminum chloride catalyst is going to come in, and the chlorine can react with it to give this intermediate, which just makes for a better leaving group. And the lone pair of electrons is going to fold down and kick that off. And that is going to give me my acylium ion. So you've got this triple bond on oxygen, which we're not so used to seeing, but it's the more stable resonance contributor because all the atoms have a full octet. This acylium ion is the electrophile for this reaction. So once the electrophile has been generated, the benzene ring can react with it, and so it's going to be attracted to this reactive intermediate here. The pi electrons in the ring will come attack the carbon because the oxygen can't accept another bond right now. It has a full octet. Attacking the carbon forces pi electrons up onto the oxygen, which alleviates that positive charge on it. So again, this is my slow step, and this introduces that formyl group. And so now I would have just a double bond to oxygen and my H there. And then I've got my positive charge here. And of course, once my positive charge is in the ring, it can go around the ring. So all this to say, there are multiple resonance contributors for this rhenium ion that is generated in the process of an electrophilic aromatic substitution reaction. And so these sort of are all, representative of that rhenium ion. And then we'll go to the next page and do our last fast step, the deprotonation. Okay, so I've redrawn one of our resonance contributors. You can actually use any of them. You just have to push your arrows correctly. In this reaction, your leaving group is going to come back and behave as the base here. And so this chlorine can come off as a chloride with a negative charge, grab that proton, and then those electrons can fold down to reform the double bond. Again, it's not a really strong base, but the restoration of the aromaticity of the compound is the driving factor here for this reaction. So that will make a benzene ring now with my formyl group on it. So I've restored aromaticity plus HCl byproduct. This is usually in the gas phase because of the temperature of this reaction. So that's going to go as a gas. And then theoretically, your catalyst is regenerated. And so then it can go back and react with another acylium ion to further facilitate the reaction. So this has been a look at the Gatterman-Koch formylation reaction. In this reaction, we swap out an H for a formyl group, which is aceto-bondo that has an H on it, so specifically an aldehyde. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.